Question number 11. If equal masses of two liquids of densities D1 and D2 are mixed together, the density of the mixture is, right, their masses are equal. Question number 11. We know that density equal mass over volume. So density of the first liquid, density of the first liquid is mass over volume. Am I right there? So density is given as D1. Mass we don't want to take M1, M2. Why? The question tells masses are equal. Okay. So I take only M. Volume is V1. So if I use cross multiplication, I can subject V1. V1 equals M over D1, first equation. Right? Similarly, I can write the same equation for the second liquid. The density of the second liquid, again it is mass over volume. Density of the second liquid is given as D2 equals mass over volume is V2. So let me take V2 to this side, D2 to there, so I can subject V2. V2 equals, for the mass let me take simple M because masses of the liquids are equal. So then we get M over D2 is M. V2 equals M over D2. Similarly, we can write the same equation for the density of the mixture. So as this is an MCQ, no need to write like this in the exam. Once you write V1 equal M over D1, V2 is M over D2, V3 is, what's it there? Density of the mixture divided by density of mass of the mixture, right? You should be able to write like that. But now I am writing the equation because this is a paper discussion. Am I sitting for an examination now? No, I am doing a paper discussion. So as I am doing a paper discussion, I write them all. I explain you, right? So again, this is equal to mass over volume. So density of the mixture is simple D. This is what we want to find. Mass is the masses of the liquids. Am I right here? Mass of the first liquid simple M, mass of the second liquid simple M. Therefore the total mass is M plus M. The total volume means volume of the first liquid plus volume of the second liquid. Right? The easiest way to simplify this, I want to obtain an expression for simple D. Yes, I know. But I take V1 plus V2 to this side. So D into V1 plus V2 equals M plus M to M. Write them all, try to simplify this and try to subject simple D. Do it yourself. Try it for the rest. Right, how to simplify this dear? Look at both. It's not such a big simplification. This is d times v1. Look at both. Stop writing. v1 is m over d1. M over d1. v2 is, just look at the second equation, m over d2. M over d2 equals 2 times m. The easiest way to simplify this is, there are many methods. One of the things that you can take m out, then d, if you take m out, this will be 1 over d1, this will be 1 over d2, m is taken out, equals to m. Now what will happen to the term simple m dear? What will happen to the term simple m? Simple m cancelled out. The m at this side, the m at other side will be cancelled out. After that, we will take a common denominator for d1 and d2 terms. When we take common denominator, we should take the product of the two denominators. Then, should multiply the numbers as a cross. This is how we take a common denominator. So then, it is d into 1 times d2 plus d1 times 1 divided by d1 into d2. The other side we have only 2 because m and m cancel that. Okay dear? So finally you get d is d2 plus d1 equals 2 divided by d1 d2. If you use cross multiplication like this, d can be subjected to d1 d2. You have taken them to this side, divided by d2 plus d1. d2 plus d1 no, d1 plus d2 no problem. So this is the correct answer. So which choice is correct here? Among the 5 answers, which choice is correct? Fifth one, right? Very good. Now then let's try for question number 12. 3 different spheres are shown in the following figure. All of them are in equilibrium. It means they are at rest. They are not moving to any direction, in simple words. But sometimes it is considered when an object is moving with a constant velocity, then it is again said that the object is in equilibrium. It means the resultant force acting on an object is 0. Moment about any point is 0. Those are the conditions for an object to be at in equilibrium. All of them are in equilibrium. In B, it floats, and in C, it fully immersed in 2 different liquids, surfaces A and D. If a small displacement is given in suitable manner, which of them are in neutral equilibrium? Neutral equilibrium means if we give a small displacement, object will be at that point without moving in any direction. Can you understand? There's an object, we give a small displacement. Then object moves to a different point and it will be at rest at that point. Okay dear? Right, so please write. When an object is in neutral equilibrium, Question number 12 and write, when an object is in neutral equilibrium, when an object is in neutral equilibrium, comma, if a small displacement is given to that object, if a small displacement is given to that object, if a small displacement is given to that object, comma, it will be moved to a new place, it will be moved to a new place, it will be moved to a new place, and it will be moved to a new place, and it will be at rest at that place. It will be at rest at that place. Right? The object will never come back to full stop and write. The object will never come back to. The object will never come back to its initial position. The object will not come back to its initial position. The object will not come back to its initial position, and the object will not be moved a larger distance, and the object will not be moved a larger distance. The object will not be moved a larger distance, a larger distance. The object will not be moved a larger distance. The object will not be moved a larger distance from its initial position. The object will not be moved a larger distance away from its initial position. Got it? Read that description, check whether you can understand it. Read the description and check whether you can understand it. Right, now check the first object, actually figure A, question number 12, figure A shows us neutral equilibrium, right? And sphere is placed on the horizontal ground If you move the sphere to this side or to the other side, it will be moved to that place and it will be at rest. It will be not moved far away from the initial position. Can you understand here? It will be slightly moved away from its initial position and it will be at rest at the new position. Okay dear? Please write. Capital A position shows a neutral equilibrium. Capital A position shows, capital A figure shows a neutral equilibrium. Capital A position shows a neutral equilibrium. Draw the figure, quick. Draw the figure. Star point and write. Capital D figure shows unstable equilibrium. Capital D figure shows unstable equilibrium. Capital D figure shows unstable equilibrium. Unstable equilibrium means this is the surface on which the object is placed, right? And this is the object. If you give a small displacement into right hand side, what will happen? It falls far away from the initial position. It will go forever. It will not come to rest. And even if you give a displacement into the other direction, again it will be moved away and it will not come back to its initial position, and it moves a larger distance. Capital D, it moves a larger distance away from the initial position when you give a small displacement. You give a small displacement. You give a very small displacement. After that, object continues to move and move far away from the initial position. Here, you give a small displacement. Object moves only that small displacement and the object comes to rest. This is neutral. This is unstable. Can you understand the difference? Neutral means you give a displacement to the object, object moves only that displacement. Neutral means you give a very small displacement, the object moves only that displacement and object comes to rest. Unstable means you give a very small displacement, we give a very small displacement, object moves far away from the initial position, and most of the time it will be moves continuously. Got it, dear? Draw this figure. Neutral, unstable. Right? You can find many similar questions in past papers. So these are compatible questions here, related to our syllabus. That's why I am asking you to discuss this kind of papers. Then what about the other third kind of equilibrium, which is said to be the stable equilibrium? Stable equilibrium is shown in figure B and figure C. You start point and write figures B and C. Figures B and C show the stable equilibrium. Figures B and C show the stable equilibrium. Figure B and C show the stable equilibrium. Figure B and C show the stable equilibrium. Okay, dear? Right. Stable means the best, I'll draw it as a note. The best way to explain stable equilibrium is this. Let's say there is a surface like this, right? An object is placed here. I give a small displacement to this side. What will happen? It will reach back to the bottom. I give a small displacement to the object upward. What will happen? It will reach back to the bottom. Got it here? So stable means object is always come to its initial position when we give a small displacement. Clear or not? In figure B, look at board. The object is, it floats. The object floats on a liquid. The object floats on a liquid. So everybody knows when an object floats in a liquid, if you push the object downward, what will happen? It always come up. If you give a small displacement upward, due to the gravity, it falls down. So it means if you push it down, it will come back. If you pull it up and release, it will falls back. Got it there? So it means the object will always come back to its initial position. Even figure C shows the same situation. There are two liquids. The object is somewhere here. One liquid is at below the sphere, something like the best example for the two liquids, water and coconut oil. Water will be at the bottom. Density of water is larger, water will be at the bottom. Coconut oil will be at the top. So the object is in the some part of the object is in water, the other part is in coconut oil. I don't know what are the two liquids. I have given just possible liquids, examples. So if you push it downward, again it will come up. If you pull it up, again it will come back to the starting point once you release the object. So stable means the objects always come back to the starting points. Unstable means objects will never come to the starting points. Stable means object will always come to the starting point. Neutral means whenever you give a small displacement, object travels only that distance and comes to rest. It will not be moved to any direction any further. Okay dear? Draw B and C and write down this note. It is essential. Note shows the best example for stable equilibrium. Draw the figures here, quick. Question number 13. An object starts from rest and moves with a constant acceleration. Which of the following graph best represents the variation of its kinetic energy? If the acceleration is constant, what should happen to the velocity? Velocity should be increased. Which graph shows the increase in kinetic energy with the time? As the object moves with an acceleration, velocity increases with the time. Only the second graph shows that kinetic energy increases with the time. Third graph, kinetic energy comes to a constant. After a certain time, it shows that kinetic energy comes to a constant. It is reduced. Can you see that one here? So third one is impossible. Only one or two. Kinetic energy equation. What is the kinetic energy equation here? Kinetic energy of any object, which number 13, half mv square. Due to v square, it should be a curve. It cannot be a straight line. So it means answer is 2. Okay, dear? Right, so please write. As the object is moving with a constant acceleration, as the object is moving with a constant acceleration, as the object is moving with a constant acceleration, its velocity should be increased with the time. Its velocity should be increased with the time. Its velocity should be increased with the time. Full stop. As the kinetic energy equation is half mv square, as the kinetic energy equation is half mv square, kinetic energy should be increased as a curve with the time. Kinetic energy should be increased as a curve with the time. It cannot be a straight line when there is a square term. Okay, dear? Kinetic energy is increased as a curve with the time. Okay, dear? So answer is 2. Will you please draw this graph? It should be a curve like this. It's better to draw the graph. So answer is 2. It is impossible for it to be a straight line. Right? Question number 14. 14. Water is flowing through a tube of non-uniform cross-section. Water flows through a tube. The cross-section area is not constant. Cross-section area changes. Place to place, the tube has a different cross-section area. If the radii of the tube at the entrance and the exit are in the ratio of 3 to 2, it means if the cross-section area at the entrance of the tube is 3, cross-section area of the tube at the end exit will be 2 square meter. That's the meaning of 3 to 2. Then the ratio of velocities of flow of water at the entrance and exit is, your dustbin please. There is a tube. Entrance should have a larger cross-section area. Exit should have a relatively smaller cross-section area. Am I right? 3 to 2. So it means if the cross-section area here A1, if the cross-section area here A2, A1 over A2 is given as 3 over 2. That's the meaning of this given ratio. That's the meaning of the given ratio. Am I right, dear? The velocities are, they ask us to find the velocity ratio. Draw the figure, dear. In the exam, no need to draw figures. But now, please draw the figure. Draw the figure for question number 13. So how do you find the velocity ratio? Just apply the equation of continuity. Just apply the equation of continuity. So what is the equation of continuity here? A1 V1 equals A2 V2. Look at both. Wait. Look at both. I'll take A2 to this side, V1 to the other side. Then what will happen? I can subject A1 over A2 equals V2 over V1. A1 over A2 is 3 over 2 equals V2 over V1. That's the problem. The question does not ask. We have to check the thing they ask, whether V1 over V2 or V2 over V2. Then the ratio of velocities of water at the entrance. Entrance means V1. Entrance and the exit. Exit is V2. Entrance to exit. It means they ask us to find V1 over V2. So as V1 over V2 is asked, take V1 to there, 3 to there, 2 to there, and V2 to this side. So then you get V1 over V2 equals 2 over 3. Even without doing a calculation, you should be able to get the answer. Smaller cross section, larger velocity. A2 is smaller, therefore velocity should be larger. A1 is larger, V1 should be smaller, so 2 over 3. You can get the answer even like that. Larger cross section area A1, therefore V1 should be smaller, 2. A2 is smaller, therefore velocity should be larger. So, but I would like to write some equation and get the answer. So, what is the correct choice among the 5 choices here? then the ratio of the velocities of the flow of water entrance and the exit. Correct answer is not given. Then that's a typing mistake. Right? Question number 15. Question number 15. The particle of mass simple m traveling with the velocity u collide theta inclined to a wall rebounds with the same speed. If the motion takes place on a vertical plane and the collision lasts for delta t time, the horizontal average force, the direction and magnitude on the wall will be force on the wall. Force on the wall is equal to force on the ball. Why? When the ball gives a force to the wall will give a force to the ball. Equal and opposite force will be given. Whose law is that? Newton's third law of motion. Even a diagram is given. When a diagram is given, question will be very easy. Look at board. Question number 14. A ball is coming along this dotted line path. It hits the ball and rebounds. Right? So this is what given in question number 14. This is a ball. Right? The ball is coming with the velocity of u. It leaves the ball with the same velocity u. What about the angles? This angle is given. Look at board. This angle is given as theta. This is theta. Right. Look at board. If it is theta, what should be this angle here? Parallel line cut by a straight line. If this is theta, this should also be theta. This angle should be theta. This should also be theta. Wait. Now I can resolve the velocities along two directions, vertical and horizontal. Velocity component towards the angle u cos theta. Velocity component away from the angle u sin theta. Am I right here? Velocity component, if this is theta, this should also be theta. Simple maths. Am I right here? No. Wrong. If this is theta, this should be theta. Otherwise no. Okay dear? Straight line cut by another straight line. Then the opposite angles are equal. One straight line cut by another straight line, therefore the opposite angles are equal. Okay dear? So then velocity component towards the angle u cos theta. Velocity component away from the angle u sin theta. Now if you check the figure carefully, vertical velocity component remain unchanged. Initial vertical velocity component u cos theta. After the collision, vertical velocity component u sin theta, u sin theta. Vertical velocity component remain unchanged. Horizontal velocity component, initially it is into right hand side. Now after the collision it is into left hand side. Magnitudes are same, it's okay, but horizontal velocity component, direction of the horizontal velocity component has been changed. Got it, dear? So therefore we should apply the impulse equation only along the horizontal direction. First of all, please draw this figure. These are the real advanced level physics questions. Okay, dear? No magic. Draw the figure. Right. Now please try only the direction of the horizontal velocity component below the figure. Please try only the direction of the horizontal velocity component is changed, has been changed due to the collision. Only the direction of the horizontal velocity component has been changed due to the collision. Has been changed due to the collision. Okay, dear? Right. Leave a line and write. Let us apply leave a line and write. Let us apply impulse equation to the ball along the horizontal direction. Let us apply impulse equation to the ball along the horizontal direction. Okay, dear. So what should be the direction of the force acting on the ball here? Earlier ball was moving to right hand side. After the collision, ball starts to move into the left hand side. I am considering the horizontal motion. So if the direction is changed from right hand to left hand, the direction of the force given by the ball definitely be acting into the left hand side direction. Am I right, dear? The force definitely be acting into the left hand side direction. So along the left hand side direction, I apply the impulse equation. Force multiplied by time equal m into final velocity minus initial velocity. Sorry, final velocity means v2 minus v1. Wait. So I apply this equation along the horizontal direction. Please wait, don't write anything. Force is the force given by the ball. Time is given as delta t. The ball is in contact. The ball is in contact with the wall for a period of delta t seconds, which is given in the question. Mass is m. Horizontal velocity component, final horizontal velocity component of the ball is u cos theta. Then I write this minus sign. What about the initial horizontal velocity component? I am applying the equation into the left hand side. Initial horizontal velocity component is into the right hand side. Am I right here? I am applying the equation into my left hand side. But initial horizontal velocity component, this u cos theta, is into right hand side. When the directions are opposite, we must use a minus sign. That's how we deal with vectors. Okay, dear? That's how we work with vectors. So f into delta t equals m into u cos theta minus into minus. Lamai? Minus into minus plus u cos theta. Okay? U cos theta plus u cos theta is, I should indicate the direction. U cos theta plus u cos theta is 2u cos theta. If I take delta t to other side, I can nicely arrange this expression as 2mu cos theta divided by delta t. So which answer is correct here? Among the 5 choices, which choice is correct? 2mu cos theta or delta theta, and check the direction. Direction should be to left hand side. Direction of the force. They ask, if the motion takes place on a vertical plane, the collision lasts delta t time, the horizontal average force on the ball. Wait. What is this force here? Wait. What is this force? This is the force. We have applied this force to the ball. So therefore this is the force acting on the ball. Acting on the ball. So this is not the answer. Magnitude is same. This is the force acting on the ball. The question asks us to find the force acting on the wall. Write them first. Write them first. So if the force acting on the ball is this, when the ball gives a force of this much to the ball should give equal and opposite force. It means magnitude will be the 2 mu cos theta over delta t, but the direction will not be in right hand side. Opposite direction means direction should be right hand side. Clear? So please write, when the wall gives the above force to the ball, when the wall gives the above force to the ball, B-A-double-L, when the wall gives the above force to the wall, when the wall gives the above force to the wall, comma, the ball should give equal and opposite force to the ball. The ball should give equal and opposite force to the wall. When the wall gives the above force, wall, W-A-L-L. When the wall gives the above force, mean this force, to the ball, comma, the ball should give equal and opposite force to the wall. Within brackets, Newton's third law of motion. Within brackets, Newton's third law of motion. Newton's third law of motion. Okay, dear? Leave a line and write the equation. Therefore, the force acting on the wall. Therefore, the force acting on the wall. Therefore, the force acting on the wall equal, direction should be into the right hand side. The magnitude will be the same, 2 mu cos theta divided by delta t. Therefore, the answer is the second choice is correct. Write the answer, read my description, check whether you can understand. So actually no need so many descriptions to obtain this answer. As the ball is traveling into the right hand side, the force given by the ball should be into the right hand side. That's it. Am I right there? The ball is moving into the right hand side. Therefore, the force given by the ball to the ball should be into the right hand side. Should be into the right hand side. No magic, right? Let's discuss the next question. Question number 16. Consider the following statements made on pressure. 3 statements given as ABC. The statements are given about the pressure. Right? Pressure is a vector. What do you think? Pressure is the force acting perpendicular to a unit area. If you consider a curved surface, pressure is always perpendicular to the surface. It means pressure does not have a constant direction, one single direction. Can you understand it? Pressure does not have a one single direction. Pressure is just perpendicular to the surface. So therefore pressure is not a vector. B. It acts always perpendicular to the surface. 100% correct. B is correct. C. Pressure on the bottom of a water tank is independent of the surface area of the bottom. Pressure acting on the bottom of a water tank is given by the equation H rho G. Do we have cross section area in the equation? No. It means C is correct. Independent of the surface area means surface area should not be considered. Whatever the surface area, the pressure will be the same. Okay, dear? Right. So please write. Pressure, put the question number 16. Pressure is the force acting normal. 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 On a unit area. On a unit area. Unit area. Okay, dear? Therefore, the pressure is always perpendicular to the surface. Pressure is always perpendicular to the surface. Pressure is always perpendicular to the surface. Therefore, statement B is correct. Therefore, statement B is correct. Okay, dear? The pressure, leave a line and write. The pressure at the bottom of a liquid tank. Pressure at the bottom of a liquid tank. The pressure at the bottom of a liquid tank. The pressure at the bottom of a liquid tank depends only on the depth. Depends only on the depth. Within brackets, H rho G. I think you remember this equation. Pressure created by a liquid is given by the equation H rho G. Only depends on the depth. Within brackets, H rho G. Therefore, pressure is independent of the surface area. Therefore, the pressure is independent. Therefore, the pressure is independent of the surface area. Pressure is independent on the surface area. Okay, dear? Therefore, statement C is correct. Therefore, the statement C is correct. Statement C is correct. Next line, next point. Pressure does not have one single direction. Pressure does not have a single direction. Pressure does not have a single direction. Pressure does not have a single direction. Therefore, pressure is not a vector quantity. Therefore, the pressure is not a vector quantity. Pressure is not a vector quantity. Okay, dear? So, for the question number 16, A is wrong, B is correct, C is correct. Please write like this. Therefore, what is the correct choice? Only B and C. Answer is O. Answer is O. Only B and C are correct. Question number 17. The velocity time graph of an object moving on a straight line is given in the following figure. Its displacement during OA and AB intervals are S1 and S2 respectively. Then the ratio S1 over S2. They have given us a velocity time graph. Question number 17. A velocity time graph is given. A velocity time graph is given. The velocity time graph of an object moving on a straight line is given in the following figure. Right? So, initially, what is this here? What is this section? Constant acceleration. So, velocity increases, constant acceleration. Then, what is this here? It's a constant deceleration. Draw the figure here. And the maximum velocity is this. V m. Maximum velocity I have marked it as Vm. Draw the graph. Mark the time durations as T1 and T2. If this is Vm, what should be this height here? This is 0, this is Vm. Therefore, this height should be Vm. Mark Vm, T1, T2. The question asks us to find displacement during T1 S1, displacement during T2 time S2. The question asks us to find the ratio S1 over S2, right? What is how do you find the acceleration from a velocity time graph? How do we find the acceleration from a velocity time graph? Acceleration is the gradient. So, acceleration during T1 seconds. How do we find it? So that is the gradient. Gradient means tan theta. Tan theta means tan 30. Am I right there? So, but tan 30 from this triangle is opposite side Vm divided by this side T1. Am I right there? So that is Vm over T1. Somebody please tell me what the tan 30 is. Sin 30 half, cos 30 root 3 over 2. Am I right here? Sin 30 divided by cos 30 is tan 30. Half divided by root 3 over 2. 2 and 2 cancelled out. 1 over root 3. Am I right here? That's people, what is tan 30? No need to do that much of things. 1 over root 3. Vm over T1. Check whether they have given T1 here, T1 over Vm, and write these things. They have not given T1. So let me interchange the terms and subject T1. So you get T1 equals square root 3 times Vm. Square root 3 times Vm. Write them all. Right, similarly, look at both. Similarly, what is the acceleration? What is the acceleration during? What is the acceleration during T2 seconds? Again, it is gradient. So it means tan value of this 60. Right? We don't care about the magnitude. So actually this is not an acceleration, it is actually a deceleration. So it's better to say this is a deceleration. Why do I say it's a deceleration? Velocity is reduced from Vm to 0. Am I right? So deceleration is tan 60. What is tan 60 dear? Root 3. So tan 60 according to the triangle, opposite side divided by adjacent side. Right? Sin 60 divided by cos 60 is tan 60. It is root 3. So root 3 equals Vm over T2. So just use cross multiplication, subject T2. So T2 is Vm divided by root 3. Vm divided by root 3. Write them all. Right. Finally, what is the displacement? I'm discussing with a very slow speed. Right. I'm not targeting only the brighter students. So our discussion is very slow because everybody should pass. Everybody should pass. All are the children of parents. Whatever the level of your parents, their wish is your good result, good education for their children. So I keep the slow, steady speed. Then everybody should understand. Everybody will be able to understand. Then everybody will pass. I'm not targeting only the brighter students. Then I can increase the speed. Then only 2-3 students will get district ranks and island ranks. All the other will fail. I don't want it to happen. I want everybody to get good results, right? So what is the displacement of a velocity time graph here? The displacement of a velocity time graph is the area under the graph. What is displacement here? Area under the graph. Okay dear? So this area gives S1 displacement, this area gives S2 displacement. I would like if you mark S1 and S2 displacements. The question asks us to find S1 over S2. S1 is the area of this triangle. What is the area of this triangle here? Half into base into perpendicular height. So it means it's a triangle half into base T1 perpendicular height Vm. S2 is again it's a triangle half base is T2 perpendicular height Vm. So it is T2 into Vm. We have expressions for T1 and T2. Replace T1, T2 by these expressions, then you can get the ratio. Half and half cancelled out. T1 into Vm divided by T2 into Vm. Replace, remove T1, T2 by these two expressions. Right here. So what is it? What's the final answer? T1 is root 3 times Vm into Vm. T2 is Vm over root 3 into Vm. What is this there? Square root 3 Vm into Vm. Vm square. Divided by Vm into Vm. Vm square. Divided by root 3. I think you know this simple maths. This root 3 can be taken up. Do you know this maths? So then what are the terms here? Square root 3 Vm square into root 3 divided by Vm square. Vm square to Vm square. Vm square to Vm square cancelled out. Root 3 into root 3 is root 3 multiplied by root 3 is 3. So among the 5 choices, which choice is correct here? Fifth answer. Fifth choice is correct. Complete here. So answer is 5. Question number 18. Harry Potter, wow, is sitting 2 meters away from the center of a merry-go-round when Draco Malfoy casts a spell that glues Harry in the place. Wow, that's good. Harry is fixed to the place where he is sitting on the merry-go-round and makes the merry-go-round start spinning on its axis. Harry has a mass of 50 kg and can withstand 5g of acceleration before getting unconscious. When the Harry is moving along a circular, the merry-go-round is rotating. Harry is on the merry-go-round. Therefore, when merry-go-round rotates, Harry is moving along a circular path. Then he has a centripetal acceleration. Am I right there? And he has, what about tangential acceleration? It does not say any about angular acceleration. So whatever, when the acceleration increases up to 5g, Harry unconscious, right? What is the magnitude of the Harry's angular momentum when he get unconscious? Please write question number 18. Please write. When the merry-go-round rotates, when the merry-go-round rotates, when the merry-go-round rotates, when the merry-go-round rotates, comma, Harry is moving along a circular path. Harry is moving along a circular path. Harry is moving along a circular path with a radius of 2 meters. With a radius of 2 meters. With a radius of 2 meters. Full stop. Okay? At a certain angular velocity, within brackets omega at a certain angular velocity within brackets omega, the centripetal acceleration becomes 5g. Centripetal acceleration becomes 5g. Full stop. Then Harry gets unconscious. Am I right here? So what is centripetal acceleration here? Centripetal acceleration equals, there are many equations, but I would like to use the equation r omega square, right? V square over r, v omega, r omega square is better. So here centripetal acceleration should becomes 5g, then Harry becomes unconscious. If I take r to this side, 5g over r equals omega square. Therefore omega is 5g over r and root of that. But r is given as how many meter here? Harry is moving along a circular path of radius 2 meter. Therefore omega is 5g over 2 square root of that. Write them more. The question asks us to find the angular momentum of Harry. Am I right? What does the question ask? Angular momentum of Harry at the time when he gets unconscious. Am I right here? So please write angular momentum of Harry equals I omega. Angular momentum of Harry equals I omega. What is I? In this case, we have to treat Harry as a point mass. Mass of Harry is given as 50 kilogram. Am I right here? Moment of inertia of a point mass moving along a circular path. Moment of inertia of a particle moving along a circular path is given by the equation mr square into omega. M is given as 50, R is given as 2, omega is square root 5g over 2. Simplify this and which answer is correct here. Check. This is 50, square of 2 is 4, 5, G is 10, 5 times 10, 50, 50 divided by 2 is 25. 50 times 4, 200. What is this thing? What is this? 5 times 10, 50. 50 divided by 2, 25. Square root of 25 is 5. Square root of 25 is 5. Then 200 times 5 is 1000 kg. What's the unit here? Moment of inertia kgm square per second. Which choice is correct here? 1000 kgm square. Answer is 4. Okay. I would like, if you then this will not become a MCQ, I would like to show you something else. But in that case, it is not an MCQ, then it becomes an essay question. Look at what it is. The first thing, question does not say the merry-go-round is moving with an angular acceleration. Let's say it is given in the question that merry-go-round is moving with an angular acceleration of alpha. Then when the Harry is moving along a circular path of radius 2 meter with an angular acceleration of alpha, right? Then at the time when he gets unconscious, he has two acceleration components. If he, I don't know, it is not given in the question. If he is moving along a circular path with a constant angular acceleration of alpha, then he has two acceleration components, the centripetal acceleration AC and the tangential acceleration AT. Then you have to find the resultant acceleration AR. Can you understand here? So what is the resultant acceleration? It is the square root of when two vectors perpendicular to each other. Resultant acceleration is AC square plus AT square. Right? At the time when Harry gets unconscious, his resultant acceleration should be 5g. So AC is 5g. Sorry, resultant acceleration 5g. AC, centripetal acceleration is given by r omega square. Tangential acceleration is given by r alpha, but again you have to take the square and root. So then you should obtain an expression for omega. By using that omega, you should do the same calculation. Got it, dear? Please write not. If the merry-go-round is rotating with a constant angular acceleration of alpha, if the merry-go-round is moving with the constant angular acceleration of alpha, Harry's resultant acceleration within brackets AR, Harry's resultant acceleration within brackets AR should be found by considering centripetal acceleration and tangential acceleration components. Centripetal acceleration and tangential acceleration components as given below. Centripetal acceleration and tangential acceleration components as given below. Please draw the figure and write down this. From this you have to find omega, but we cannot use this method because question does not tell us merry-go-round is rotating with an angular acceleration. But if it is said that merry-go-round is rotating with a constant angular acceleration, this is the method that you should use. Draw the figure and write them all quick. Question number 20. When a sound wave of, question number 19. The figure shows a wave on a water surface at at the time t equals 0. There's a small object floating on the surface. The path of its motion during a single period capital T is best represented by water surface wave. Water surface waves are transverse waves. When a wave travels to a certain direction, particles in the medium oscillated perpendicular to the traveling direction. When a wave travels to a certain direction, particles in the medium oscillate perpendicular to the traveling direction of the wave. Traveling direction of the wave. Perpendicular to the traveling direction. So it means wave travels to this direction. What about the particle here? This particle is just going downward and coming upward along the same straight line path. The motion takes place along the same straight line path. Therefore, the answer is 4. This should be a straight line. Draw the figure. This is just the definition. The wave travels horizontally, particles oscillate vertically along a straight line like this. It's a straight line. Answer is 4. Draw the figure. Question number 20. When a sound wave of frequency 300 Hz passes through a medium, the maximum displacement of a particle of the medium is 0.1 centimeter. What is the maximum distance traveled by the particle from its mean position? 0.1 centimeter. The maximum velocity of the particle is equal to. So when a sound wave travels in a medium, look at board here. Let's say there is a sound source. There is a sound source. It sends a sound wave. It sends a sound wave. Then what will happen to the particles in the medium? The particle will be travel along the same direction, comes back to its original position, travels to the opposite direction and comes back to the original position. So it means the particle, this is a particle, the particle oscillate along the same direction with the wave. This kind of a wave is said to be a longitudinal wave. Sound is a longitudinal wave. So, if the frequency of the wave is 300 Hz, frequency of the oscillating particle is also 300 Hz. It means the particle will complete, this is said to be a one cycle. This is said to be a one cycle. The particle will complete 300 such cycles within 1 second. The particle will complete 300 this kind of cycles within 1 second. Right? That's the meaning. Right? So please try it. As the frequency of the wave is 300 hertz, as the frequency of the wave is 300 hertz, as the frequency of the wave is 300 hertz, comma, the frequency of the vibrating particles, the frequency of the vibrating particles in the medium, the frequency of the vibrating particles in the medium is also 300 hertz. The frequency of the vibrating particles in the medium is also 300 hertz. Full stop. It can be assumed that particles are oscillated as a simple harmonic motion. It can be assumed that the particles are oscillated as a simple harmonic motion. As a simple harmonic motion. Okay, dear? So, what is this amplitude here? Look at board. What is the amplitude? The amplitude of the particle is given as 0.1 centimeter. Leave a line and write. The amplitude of a vibrating particle. The amplitude of a vibrating particle is given as 0.1 centimeter. Is given as 0.1 centimeter. Okay, dear? Draw this figure. This one. Okay, dear? Right. What is the velocity equation of a simple harmonic motion? Velocity equation of a simple harmonic motion is V equal plus or minus omega times, don't write anything, don't write, square root of A square minus x square. X is the displacement of the particle from the mean position. Mean position is the maximum velocity position. It means the middle position. At the middle position, displacement is 0. When the particle is at exact middle position, displacement is 0, then the velocity is maximum. Even from this equation, x is subtracting, x is reducing. Therefore, when x is minimum, velocity should be maximum. So it means when displacement, when x is 0, the velocity v should be maximum. So what are the two methods here? When the particle is at the middle position, velocity is maximum. We have learned it under simple harmonic motion. When the particle is at the mean position, displacement is 0. Therefore, velocity maximum, displacement x is 0. Even from this equation, according to this equation, v will be larger when x is smaller. the smallest value of x is 0. When x is 0, V will be maximum. Don't write. V is maximum plus or minus omega when x is minimum. When x is minimum. Minimum value of x is 0. Therefore, V is maximum plus or minus omega times square root a square minus 0. What is a square minus 0? A. A square minus 0 is a square. What is the square root of a square? A square minus 0 is a square. Square root of a square is a. Therefore, don't write. Maximum velocity is plus or minus omega a. But we have a problem. We don't know what the omega is. So how do you find omega here? To find omega, we can use this equation. Omega equals 2 pi f. So omega is 2 pi. F is given as 300 hertz. 2 times 300, 600. Omega is 600 times 5. First you write this, after that write this and find omega max. And do not forget, amplitude should be given in meters. Check the answers here. Answers are also given in centimeters. So don't convert amplitude into meters. Check the answers. In the answers, centimeter is the unit. Therefore, no need to convert centimeter amplitude into meter. Try it. Write them all. So what is maximum frequency? Sorry, maximum velocity. So V max equals plus or minus omega A. Omega is 600 times 5, A is 0.1 centimeter. 0.1 means 1 over 10, so 1 of the zeros cancelled out. 60 times 5 unit is centimeter per second. So which choice is correct? Which choice is correct? Third answer is correct. Am I right here? Answer is correct.